This is Unit 5, Lesson 4. We're still solving quadratic equations. We're going to be solving quadratic equations by using the quadratic formula. This is actually the last method we're going to be going over to solve quadratic equations. So, this formula is, I'm going to just give it to you, x is equal to, which is our solution, negative b plus or minus the square root of b squared minus 4ac over 2a. And this formula only works when the equation is in standard form. So your equations need to look like this. ax squared plus bx plus c. Okay, let's take a look at example 1. The directions will say solve. I've got x squared plus 8x plus 12. So my first step is I'm going to go through and label what a is, what b is, and what c is. So a is the number in front of the x squared, that's 1. B is 8. C is 12. So I'm going to take the information that I have and I'm going to substitute in. So I've got negative b plus or minus negative b, so I'm taking the opposite of a positive 8, I'm putting a negative 8. Then it goes the square root of b squared, so that's 8. The square root of 8 squared minus the 4 is always part of the formula, so that's not going to change. A is 1, c is 12 over 2 times 1. I just took those numbers and substituted in. Wherever I saw a B, I put an 8. Wherever I saw an A, I put a 1. And wherever I saw a C, I put a 12. Now let's do the work. Once we call this plug and chug. Substitute in the numbers, do the work. So I've got negative 8 plus or minus the square root of 64 minus 48 over 2. That's giving us negative 8 plus or minus the square root of 16 over 2. The square root of 16 is going to give us 4. So I have negative 8 plus or minus 4 over 2. Now, I'm trying to work this down to one number. Because this was a perfect square, I probably should have said this at the beginning, but we're going to scroll back up here to the original formula. This is what we call the discriminant. The discriminant, what's underneath that radical sign. So I knew that number was a perfect square. So that's telling me when it's a perfect square and it's not a 0. If it's a perfect square and not a 0, I'm going to be getting 2 solutions, 2 of them. So I've got negative 8 plus 4 over 2 or negative 8 minus 4 over 2. That plus or minus I've got to break up. So I've got negative 4 over 2, which gives us negative 2. Negative 12 over 2, which gives us negative 6. That means if I were to graph this quadratic equation, this graph would hit the x-axis at negative 2 and negative 6. Let's take a look at number 2. I've got x squared minus 3x minus 2 is equal to 0. Let's move that over so you can see a little bit better. Okay, our a is 1, our b is negative 3, our c is negative 2. That's going to be your first step. You're going to label. Now I'm going to substitute in. The formula starts with negative b. Well, I've got a negative 3, so I'm going to put a positive 3 plus or minus the square root of negative 3 squared minus 4 times a, which is 1 times c, which is negative 2, over 2 times 1. Let's do the math. 3 plus or minus the square root of 9. Negative 3 squared is 9. Negative 4 times 1 times negative 2 is a positive 8 over 2. Now here's what happens with this one. It's not a perfect square. I still have two solutions. So when this number is not a perfect square, you still have two solutions, but we call them irrational solutions because this number is not a perfect square. You're still going to have two, but they'll be irrational. But you can leave it just like that, or you can separate it. You can do this or write 3 plus square root of 17 over 2, or 3 minus the square root of 17 over 2. Now you're going to end up getting a decimal for this. That's why it's an irrational number. But you don't need to change it into a decimal. You can leave it just like that. Let's take a look at number 3. There we go. Number 3, we have x squared minus 7x plus 1 is equal to 0. All right, my a is 1, my b is negative 7, my c is 1. So we're going to start off with negative b. Well, b is a negative 7, so we have positive 7 plus or minus the square root of negative 7 squared minus 4 times a, which is 1, times c, which is 1, and then 2 times 1. All right, I've got 7 plus or minus the square root of 49 minus 4 over 2, which gives us 7 plus or minus the square root of 45 over 2. Now 45 is not a perfect square. So the discriminant is telling me I'm going to have two irrational solutions. But I can break down that 45 just because this is not a perfect square. I probably should have said this in the previous problem. But it doesn't mean I stop. I need to see, can I break down that 45 and take anything out? Well, yeah. I can break down, this is just simplifying a radical. I can group a 3 together. So it's 7 plus or minus 3 square root of 5 over 2. That 3 comes from there. That 5 is what's left over. Now I'm looking to see this number, and this number. Is there a common factor here I can reduce it? No. So I stop there. Let's take a look at number 4, last problem. Let's take a look at when the a is not a 1. We didn't really take a look at a problem where the a is not a 1. So my a is 2, my b is 4, my c is negative 30. So it starts off with negative b. It's a positive 4, so I'm going to write negative 4 plus or minus the square root of 4 squared minus 4 times a, which is 2, times negative 30, over 2 times 2. Okay, let's do the math on this. -4 plus or minus the square root of 16. I've got minus a negative, that becomes a plus. And then I've got 240 over -4. Let's add this up. I'm getting -4 plus or minus the square root of 256 over -4. That should be a positive 4. Make that a positive. Okay, so the square root of 256, that's giving us 16. Now 256 is a perfect square, so I knew I was going to get two rational solutions. Two rational solutions. So I've got -4 plus 16 over 4, or -4 minus 16 over 4. So this is giving me 12 over 4, which gives us 3. -20 over 4, which gives us -5. So my solution is 3 and -5. I think I'm going to do one more. If I were to graph this problem, it would cross the x-axis at 3 and -5. Last problem, number 5. Let's do x squared minus 8x plus 16 is equal to 0. So my a is 1, my b is -8, my c is 16. So when I substitute in a -8, I get a positive 8 plus or minus the square root of -8 squared minus 4 times a, which is 1, times 16, times c, which is 16, over 2 times 1. I've got 8 plus or minus the square root of 64 minus 64 over 2. So here's what happens with this problem. When I do the work, I'm getting the square root of 0. So when the 0 is the discriminant, which it is here, that means I'm only going to have one solution. One. And that solution is going to be 4. And if we think of that visually, what our graph looks like, if I were to graph this, there would be one solution, and that point's going to be right on the x-axis at 4. And that is solving equations by using the quadratic formula.